Welcome to this session on Prioritising Retrofit. I'm Susie Nelson. I'm one of the coordinators of ACAN, the Architects Climate Action Network. And I was going to say a little bit about Architects Climate Action Network before introducing the speakers. The Architects Climate Action Network is a network of built environment professionals. It's not just architects, so please, everybody working in the built environment, concerned about the built environment, is welcome to join us. And we have three key main aims: decarbonise now, ecological regeneration, and cultural transformation. Well, we've got two speakers today. That Simon Sturgis is going to speak first. He's the founder of Targeting Zero, and he's a widely acknowledged expert in embodied carbon. He has advised lots of organisations, including RICS, REBA, and the Greater London Authority. And then we have Chris Procter, who is the director of Procter Architects, and he is the principal author of the Architects Climate Action Network Climate Emergency Conservation Area Toolkit, which he'll be talking about. So over to Chris. Over to Simon. Wrong order.
Well, you might get a more interesting slideshow if Chris went first. Thank you. Right, this is called demolition, but I'm just going to talk about, in fact, I'm going to sort of give a bit of an overview from where I've been sort of coming from, and then I'm going to show you some case studies. So the first thing I wanted to make, the point I wanted to make, and there are various versions of this statistic, if you like, but that global construction is reckoned to be something like one new Greater London every 6 weeks. So that's a vast amount of construction. And apart from the resources issue, there's obviously a carbon issue. The other point I would make is that, and I think this was in the blurb that was provided before this, but basically about 10 to 15% of global emissions come from construction of buildings, which means that if you look at this diagram here, that in terms of existential threats to humanity, construction at the moment is arguably worse than nuclear war, which is a kind of quite a out there thing possibly to suggest. But given that if this was to happen, it would happen in various places, whereas at the moment, carbon emissions and the impacts are everywhere. So, you know, there is a significant issue. So I'm quoting here, this is Mark Carney, who used to be governor of the Bank of England, and he was also chair of the Financial Stability Board, and he said, we can't get to net zero by flipping a green switch. We need to rewire our entire economies. And so this was the head money man, if you like, and he's not talking about fiddling around with BRIAM or anything like that. What he's talking about here is, you know, major shift in how we do things. What I'm showing you here is what is currently the government's trajectory to net zero. So at the top there, we've got net zero by 2050, and that is that was legislation passed in 2019. And then we have 78% reductions by 2035 and 68% reductions by 2030. Now, if you put those all on a graph, that's what it looks like. So zero reductions up at the top left there, down to 100% reductions here. And the COP26 and the Act of Parliament, both in 2021, occur mysteriously absolutely on that line. So that is, if you like, the trajectory we should be working to. And if you then look at this a bit more closely, you can draw an arrow which drops down to where we are today. And what you find is that most new build happens above that line, and major retrofits and refurbishment, and indeed, of course, low carbon new build will occur below the line. The reason why you've got a red bit here is because that represents, if you like, a lick of paint approach to a building where you're basically throwing stuff away. You're not producing anything valuable. So that's kind of more or less what a trajectory looks like. And then what I put in that blue line there, if you are trying to do a cost-neutral new build, you will find that the supply chain will enable you to get down about 30-ish% without it costing your project more money. So that tends to be a limiting factor. But of course, we have to do better because we need to get down to this line. And certainly by 2025, we need to get down to something like 60% reductions in comparison to where we were in 1990. So I'm just going to talk briefly about 4 different projects, all of which I've been involved with one way or the other. And the first of these is Selkirk House. And Selkirk House, on the left there, you've got the tower is a travel lodge and is what's there at the moment. And this has now been this scheme on the right here has now just been consented. And I'm going to say just a little bit about that. So there's a lot of detail here, but don't worry about that. What this is really saying, there were various problems, because I analyzed this in quite some detail. And the first problem was that there was a complete failure in the planning submission, to meet sustainability commitments that have been made by Camden. So Camden said, we will get to net zero ahead of 2050, we'll get there by 2030. And in fact, what this is showing, that was nowhere near. There were also major discrepancies in their carbon assessments. So there was a lot of errors and mistakes and things, and optimism and what have you. There was also, in the submission, there was failure to meet all the sort of obvious targets like LETI, REBA, GLA, and so on. And so, other major discrepancies in comparing new build and retrofit. So the point about all this is, and there's other things to do with how they mark themselves, nonsense about floor-to-ceiling heights and so on, and they exaggerate all the problems. And the point of all this is that Camden was so determined to approve this. What their motives were, I'm not sure, given that there is a massive excess of office space in London at the moment, and there's a massive shortage of housing. So you'd think somebody like Camden would add that up and work out that this is much better being used as residential or equivalent. But the point about this is that the planning system as it sits at the moment encourages you to look at retrofit, but it doesn't force it. So what happens is that people go through the motions and then say, oh, tragically, we can't make it work. Now, we had exactly the same thing with Marks & Spencer in Oxford Street. And for those of you who've been following the news, you will know that the High Court has sent it back to the Secretary of State. So now this doesn't mean at the moment that it's got consent, but it probably means that it will get consent. Actually, as it happens, we were surprised that we got as far as we did. We never thought the Secretary of State would rule in our favour initially. But what you're talking about for the Marks & Spencer project is you've got 3 buildings. The one in the middle is the one that we're all familiar with, but the site includes one on either side, and there's a sort of a low block at the back. And you'll see that 2 of these are less than 50 years old. And it seems incredible that we should be demolishing buildings of that age. And this happens in many occasions. Now, the argument from Marks & Spencer was that they'd done all these 16 number refurbishment studies. In fact, not one of those is actually a straightforward refurbishment. They're all, again, fiddling the books, if you like. And then they had what I'm calling here a lick of paint option, which, as I mentioned a bit earlier, was at the bottom of that arrow. So lick of paint option is fundamentally inefficient. And what they did was they compared the lick of paint option with the new build. And of course, that quite clearly showed that a new build was great. The other thing that was interesting was that underneath the mayhem, if you go inside the existing Marks & Spencer shop, it's chaotic in there. And you think, this is hopeless. Any agent would think it was hopeless. But actually, underneath it all is a very straightforward structure. And this is from Arup's structural survey. And so underneath all this mayhem is a very simple thing. And if you stripped all that out you'd have a very clean, straightforward building that you could easily make work well. The other thing is that Marks and Spencer claimed this was a retail-led scheme. Now, in fact, the only bit of retail they've committed to is this bit here at the ground level. They've given themselves the option in the planning submission to go up to 10,000 square meters, roughly, of office space, sorry, of retail space. But the existing building has 30,000, so they've got rid of 20,000, and why that should be sort of supporting Oxford Street more than what is currently existing. This is a sort of a simple diagram that I did to show that actually you could get most of the benefits in a refurbishment. And then the office floors, what this is trying to show is that once you cleared out, you could put this core in the same place, and actually the whole thing would work very much like the new build. The other thing was that the Marks and Spencer have been claiming that the new build is the greenest building, you know, in London, all this sort of stuff. In fact, where that red dotted line is, they're building down another 2 levels of basement, which is horrifically bad in terms of carbon emissions. So all round, the Marks and Spencer scheme was a kind of smoke and mirrors exercise, and they may well get consent for it. And I think what that means is that the national planning policy framework, which sort of determines these things, obviously needs fixing, because it does not align itself with the government's trajectory to net zero. So in other words, the government's produced this trajectory to net zero, but they haven't produced the teeth, if you like, to make it work. So this one here is Bastion House, London Wall West, which has a sort of similar sort of saga. I won't go through to quite so much detail, but what they did was the architects looked at, as you see here, 9 options. Now, the one in the red box, major refurbishment, they discounted as inefficient and hopeless. In fact, they'd done a parallel exercise, a commercial exercise with developers, and they got 3 developers who all said they would do this scheme, the one that was discounted in the final analysis, and that scheme, and not only that, the developers produced the kind of money that the city was looking for. So at the moment, what's happening is it's going through the planning process, and I guess that what they're going to do is if they get planning for a new build, they will discount this, because this is a poacher and gamekeeper thing. What's happening is the city is adjudicating the scheme that they are the landlord for. So make that of what you will. So you can see here, this green line represents what I think they could do with a refurbishment, and this is where it's actually going to be. So again, it's sort of a smoke and mirrors thing. They don't come clean with the information, and they're pushing a different agenda, i.e. we just want to get on and build a new building. The final one is Liverpool Street Station, Herzog de Meuron, which this is the Broadgate as you have now, and this is the proposed scheme, these 2 buildings here. And it sits over Liverpool Street Station. And you can see from this diagram, basically what it does is it drops in behind and on top of and through that. And it is a massive scheme. And in fact, the carbon emissions associated with that are enormous. They're way out of scale with the GLA things, the GLA targets and so on. And the red in this is one of the submission diagrams. The red is what is going to be demolished, and the grey is what's being retained. So you can see that actually there's wholesale demolition of actually buildings that could be reused if they just rejig the scheme a certain amount. So what I did was I sort of worked out, being fairly generous, I think, what the Liverpool Street Station submission looks like based on the figures they've produced and where they needed to be here. And you see, this is where they should be, 680 kilograms per square meter, but they're 1,437. So, you know, there is no way that this is a carbon efficient scheme. And of course, it includes a lot of demolition. So I thought I'd try and do a sort of sketch out what I thought would happen. So I've tried to do the diagram here. This is showing a kind of typical streetscape, if you like, entirely theoretical, made up of a few sites. And I think the recognition is that you would have to demolish certain things if you wish to make the whole site more efficient, and by that I mean optimize the existing material. Because what my feeling is that we should retain as much as we can, but we should also, on a carbon cost benefit basis, assess what should be taken away in order to make things overall better. Because you have a site, and the objective then is to fill in the site. Now, what I'm suggesting with this kind of an approach is that, in essence, we reuse as much as we possibly can, but allow ourselves to build higher based on what the urban infrastructure can take, rather than necessarily saying, well, we've got to respect the existing architecture. Now, this is where I sort of change direction from people like Save and so on. But and again, I think you either keep existing basements, but you don't build new ones. And I've just had these two, which I thought were kind of, I'm not promoting the fully glazed facade by any means, but the point about this is to say, you can put buildings on top of buildings, and they can be architecturally very different. Whereas in this country, we tend to go with, well, we've got to respect the existing building. And I'm saying, well, maybe we should be a bit more adventurous with this. Obviously, if it's a sort of grade 1 listed and it's superior, fantastic architecture, we should take maybe a slightly more kind of reticent approach. But I think for a lot of buildings, the interest and excitement could well be architecturally in the overlap of these different types of architecture. Thank you very much.
Thank you very much, Simon. Over to you, Chris.
Right. I'm the author of the the Climate Emergency Conservation Area Toolkit. It's a bit of a mouthful, but it's clear what it's about. And you probably have seen it because we launched it last year here at EcoBuild, the print copy, and it's downloadable with a PDF on the website. But there's still a few hard copies left, and Reba is selling it. And we had some at the stand, but you can go to Reba. But you can also do email directly to me, and we can send out the few that we have. But it's a PDF downloadable. So it was this idea to research one particular conservation area and see what numbers came up, see what was interesting about it. And I found that there's a lot of things that could be learned, the planners could learn about. And if we look at what the challenge is, we've got this big, a massive challenge to 2050. And what do we have to do to achieve that? We have to go combustion free. We have to not burn anything. We have to stop burning. So that's first. And we also have to reduce our energy demand. Heat pumps alone will not achieve what we need to do. And Letty has suggested that we need to do a 62% reduction of space heating. This is for homes. Most of my focus now is on homes, which is 20% of our carbon in the UK. So Letty has suggested that the existing area of our existing stock is here, and we have to shift this wholesale back to here. So it's a big change. And we also have to electrify, which is the no burning. And, if we just think about electrifying, our bills would be too high and we would have problems with the grid supplying enough energy. So we have to do both. We have to change from petrol to electricity. We have to reduce the demand. This was a particular project that I did in my office, looking at a very leaky old house in a conservation area, and using Retrofit and Passive House, it could come down to this level. And this is a non-listed house, and I took certain stances with it. I was able to use some Passive House ideas I'll show you later. But this is a house that was out of the ordinary. So it's that kind of move that we need to do. So what I'm proposing is Retrofit 2.0, which I'm kind of drawing from the experience we've had with retrofit to date. It's slowly moving and gradually adjusting, and historic England is gradually moving their position, allowing slimline double glazing maybe, but they're not realizing that there's vacuum glazing, there's all these other things coming. And we have to just sort of radically think, to get that big shift, to move that far, we need to think, a new way of thinking about retrofit. And so retrofit, you think about all the components of a building to retrofit. And so in the guide, I looked at the components in terms of heritage. But today, I'm just talking about 4 things that I think kind of stand out. And I think extensions can be retrofit. Most people do not think extensions are retrofit. They think when you retrofit your house, you're insulating your house. But extensions actually can pay for the retrofit. Retrofit's so expensive. Why can't we use the additional space offsets to offset upgrade to the old fabric? And I think this is really important lesson that people need to think about. And I'm going to illustrate it in a few different ways. One is the low carbon extension is the roof. That can be timber. We don't need steel up there. It's got a foundation. It's got the house below it. So a lot of terrace houses may have bad roofs or may have flat roofs. You can extend it quite easily. And of course, obviously basements are the worst, as Simon was mentioning. Rear extensions are in between because the carbon cost is in the foundation for these things. And, this could be timber and low energy, but the cost is in the foundation. Maybe there's a way to do the foundation a little differently. But if we look at this, then a priority could be roofs and roof extensions in terms of carbon setting. And what this does is this puts a woolly hat on top of your building. I'll get to that. Well, let's see. So what we're doing with roof extensions is we are capping the building where the heat loss is at the most, as heat going out the top. We can cap it with state-of-the-art sort of new construction technology with a new meeting building regs or surpassing building regs at the roof level. And that gives great benefit for the rest of the building. So if we look now how people are doing mansards. So mansards, this is from Islington Guidance. This is Islington Guidance current practice document, 6 years out of date now. And they're suggesting you can do a modern box, and they're showing this diagram. You have thermal bridge areas, problem areas. You have no sun overhang to shade this big window. And here's an example. This glass box extension here, it's set back. And it was actually a new building, but it's an extension idea that is still in the heads of planners, but it's not understanding the tectonics of the building. Also, if you look at mansards, there's another way of extending with a mansard, and there are problems with this in terms of coal bridges, and the roofs are often not thick enough. The insulation in the roof is the most important. We need to allow space to insulate the roof. And I would suggest 300 mil. And most people are so concerned with height restrictions in planning areas that they're making very low ceiling heights in these attic rooms and making very low space for the insulation. So you only have to result to high performance plastic insulation to achieve anything. We should be more tolerant for insulation and height. We should change the height. So if we look in detail, there are other ways to do things. If we have a cold roof, we have a lot of space in here to really fill in lots of insulation. And you can put cellulose fill or fiberglass. You could really overdo it. And there are certain levels of building regs that I put here. This is in the guide as an idea to sort of think about. Planners need to understand the layer of wrapping of the roof. And they need to understand, we all should start thinking, how do we wrap a roof to the walls? On heritage or on many buildings, the front facade is the beautiful thing you want to retain. The front facade, you wouldn't touch. You'd insulate inside the space. But on the rear, you can often cases insulate the wall on the rear as external wall insulation. So if you're doing that, you don't want to set back and have a parapet. You want to cover the parapet. So we need to think that we wrap the insulation from the inside up and around to the outside. And this has to be part of the thinking about extensions, that we can protect and wrap this rear wall. So conversely, with sort of a modern kind of extension, where you might have a bit of a terrace behind a parapet or something, these are just scheme ideas. But you might think, you want a delicate and sort of modern detail of a very thin roof, but then you allow space to taper back and make space for the insulation. That has to be done. And then you think of how you wrap and condense, connect it to any future internal insulation. Because you may do this without doing some of the other elements. You may not do the wall insulation, but you might in the future. So you think, how can this connect? And at the back, how does this connect on the outside? And it's because we have public realm and we have private realm. And in planning, a lot of emphasis is on the public realm. That has to meet the community and the heritage standards. But the private realm is more flexible. And I'm not talking about listed buildings. I'm talking about conservation area buildings that are more generic. And there's scope to do things in the back. Okay, another form of extension is a rear extension. Now, why put the insulation against the mass wall? So you're spending a lot of money to insulate the house, and you're covering up maybe perhaps beautiful brickwork. Why not pull it away and use that internal space as additional space and keep the brickwork inside your house, the mass inside your house, and beautiful brickwork on the back? Why put it here? Why not just move it out and use this space? And this can pay for the upgrade. So we need to think, if we're extending out the back, how we're doing it in terms of form factor. We're creating this new kind of wrapped area. We don't want to have lots of surface volume and surface area. We have to think the efficiency of cozying up to your neighbor, especially with terraces. And you get a lot of these extensions. Maybe some of them are original, some of them have been added. But then you think, if you're going to add new extensions, share the party walls. Build it to fit within the party walls so that you have the least surface area. And this is quite important form factor, rather than extend it too far out, share the wall. So you might do something like this. So you have a rear extension and you expose the brickwork as part of the space, and you've done it to the highest standard, and you may have underfloor heating. This was an option of inside a historic house if you take this out or you keep the existing floor. There are different ways to do this, but the idea is to keep this space with wrapping and the mass is inside and not a lot of glazing. If this is south, you have to think how you're shading and not doing like a glass box, because that defeats the purpose of the retrofit. So every house is a power station. Solar now is so affordable, and the technology is really completely mature. We have solar panels that have 40-year warranties. How many products in the building industry have a 40-year warranty? This is pretty amazing. This SunPower Maxion has a 40-year warranty that will keep generating 88% of its energy in the year 40. So if you think about it, that is going to slowly degrade over time, but that solar panel is going to last 100 years, or it's going to last a long time. There's no point in taking out a solar panel if it's still generating 70% of your electricity, or 60%. It's still useful. And so there's mature technology. And if you look at London, we have a solar map. We have data that shows every rooftop in London, and it's through the mayor's maps, London government, and it shows the amount of generation on particular roofs. So we have resources there that'll help us. In my neighborhood, 31% of the roofs are solar ready. So this is a heritage area, conservation area, but a lot of the roofs have a flat at the top, flat extended mansards, other flat roofs. And there are some London roofs, butterfly roofs, where you can easily put solar hidden within the roof. So we found that through counting and looking down with Google Maps, 31% is already there. It's available to use. You don't have to do anything to change the architecture. And the type of system, if you have a flat roof, I really like east-west. And these are systems that can cover the entire roof with a very low 15-degree angle. So what it does is it puts more panels on the roof, even though it may not be exactly oriented toward the winter sun. It does better in the summer. And this particular small example has 16 panels. If you're doing them oriented toward the south, let's say the south is here, and you're doing them this way, you maybe get 12. You wouldn't get as many because you have shadows from the panels up, on the angle. This is Greenpeace, and it's near us, and it's completely covered with east-west. So north and south are top and bottom. And it is very efficient because of where we are in London. This is the sun path in London, and the red is summer, the blue is winter, and this is spring and autumn in between. And if you look at the summer, the sun is really coming from the northeast and setting in the northwest. There's a large scope out here where a panel traditionally set this way wouldn't get any sun on it. So east-west sound counterintuitive, but actually, depending on where you are on the planet, there can be generation from the morning sun or afternoon sun. It does lose in the winter. That's the drawback on this. But it gets you more panels on the roof. So you have to think of the cumulative. So that you might generate less, but you do quite a bit. You do quite well.
Liz, can I ask you to speed up so we can get some questions?
Yeah. All right. So just a few more slides. So if this is a particular study of a particular roof that was oriented 37 degrees west of south, and even doing that, it didn't make much difference between the different panels. Mechanicals light, this is the last thing. I think with heat pumps, we overemphasize heat pumps. We overemphasize these big, massive heat pumps that get 7,500 pounds. There are actually 8 types of heat pumps. There are other types of heat pumps. There's not just the 2, ground source and air source. There are other types. And the one that I like is the air conditioning, which is 75-year-old technology from Japan. And it's cheap. It's around. And some countries, Ireland, will give you a grant for one of those up to 3,500 euros. USA and Vermont will give a direct grant, 350 to 850. They're granted, grants available. Here we don't have that. So just to look at mechanicals light, this is a proposal for a flat, and there's a roof extension, high spec. There's external insulation on the back, in the front. So there are simple systems. There's the condenser exterior unit here, and then there are 3 internal delivery units, 1 per room, and you can go up to 5. And this is very inexpensive to put in with this kind of technology. You can heat this if you've insulated. And then a very small mechanical ventilation heat recovery system here with an easy source of pipes. So vacuum glazing, last one is windows. Vacuum glazing is the next big thing. And a vacuum glazing can be similar to triple glazing, rather than this emphasis on double glazing and slimline double glazing. Vacuum glazing is the next thing. And this is the last slide. There are 3 generations of vacuum glass. The first one was the Japanese Pilkington after research in Australia, and this was the main one, Spaceship. But now we've got currently in the market in the UK, we've got a Belgian glass and a Chinese glass, and they have pros and cons. But there are 3 more Chinese companies developing vacuum glass, and they're bringing the price down. So this vacuum glazing is going to be something that we have to think about. It is coming, and it can be more efficient, and the price will come down. Right now, it is a bit expensive. Yeah.
Thanks very much, Chris. Sorry to rush you. Can we have? We've got a very short time for a few questions.
I'm a surveyor, so I look at existing buildings, sometimes listed, some mainly not. Party Wall, etc. Act came in 95, 96. It was enacted. I have a house in Lambeth, which is part of London, inner London, LCC. So it was under the London Building Acts, and my neighbours, I don't live there, but I'm selling it, on either side have built extensions to the rear and avoided doing a party wall thing. I couldn't enforce it. Ergo, when I sell it, someone wants to extend, there's going to be a gap, which is going to be a nightmare to maintain, and you've got heat loss. Can someone lobby the government so you enforce if someone wants to? The London Building, the Party Wall Act needs rewriting, in my opinion, coming from a surveyor point of view, because then you would save heat loss between that, and also maintenance is a nightmare. That is a real problem, and the builders avoided doing that. I said, well, we could agree, but I couldn't enforce it, and yes. Is there anything we can do about that? Under the Act, you can't do very much. But I think you need to change it. Have you got any solutions? Because you had a nice picture. It didn't really work. It doesn't work.
I could just say, but you had to get planning permission for the extension. So yeah, but it should be with. Yeah. Okay, but this should be covered with the planning permission. It should be contingent. The planning permission could be contingent on doing something in a certain way. And we need pattern books. We need ways to do things. And we need planners to actually suggest how it should be done as a condition. Okay.
I have a question here.
Okay, you touched upon maybe the answer to my question there regarding the different solutions you mentioned on the roofs and so on. Is it a case, because really administrators don't have I think don't have the capacity, or it's a long road to get to having the capacity to know all of these patterns, to know all of these solutions. Is it a case of mainstreaming these best practices as much as possible, or is there a way of like a new regulatory tool that gives wiggle room, provided there are proofs of the environmental performance benefits and so on? Like, what's a flexible mechanism that doesn't allow for, doesn't open Pandora's box of everyone doing random different things that might not work that well actually, but that go towards what you were suggesting?
I'm an advocate of pattern book and a supplementary planning document that councils are working on and developing, where they suggest how they want you to do things. Now, working within conservation, you have a lot of tools. Planners can tell us how to do things within conservation. But I think, if it's non-conservation, it's a bit more difficult because you have permitted development. So some things are local and some are national. There has to be research and publish ways of doing things that make sense. Yeah.
Got another question here.
Hi. I'm Barbara McFarlane, an architect. My question's for Simon, really. And the schemes you showed were commercial schemes. What's your view about estate regeneration projects? For example, Woodbury Down Estate in Hackney, where the idea is to demolish 100% over a period of 30 years and rebuild. There's been no scope for refurbishment. Used to house over 2,000 social homes, and we'll be lucky if we get 1,000 social homes out of a total of about 5,500 flats.
Yeah, I've come across this issue before, and sometimes it's to do with an equation, to do with local authorities wanting to say they've produced a lot more housing. So they might demolish 500 houses so they can build 1,000. So that makes them look good from a 500 plus point. But I think that the sort of underlying point really is that my personal view is that if we're going to meet and deal with the climate crisis, we've got to actually rethink how we do things. And we've got to actually start from the perspective that we do the best we can with existing buildings. Now, obviously, some buildings are beyond, useful repair. But I think as a sort of starting point, people should be really sort of forced, if you like, to follow that route. And I think, come back to the National Planning Project. So, your example you gave, I was briefly involved with Cressingham Gardens with exactly the same problem. And they're weirdly designed from today's perspective in some respects. You get cold bridging, all this kind of thing. But I think we've got to work out, and the sort of solutions that Chris has been talking about, there are ways to fix these things. And we need to focus on that rather than try and start from the perspective of knocking down and rebuilding. Obviously, we have a housing crisis. We need more housing, and it's these quite often these seem irreconcilable, but they, I think we've got to be more imaginative of what we do with existing buildings.
Just a quick one to follow up on that last point. Do you think it would be appropriate to force policy that makes demolition really difficult?
Yes, I do. At the moment, in London, for example, policy SI2, I wrote the words, and I wish I'd done them differently now, because I said prioritise retrofit. The thing is, it's very difficult to force people to start with retrofit, but I think the GLA, I think, is starting to think about this a bit more. But we also just need to get people to do what they say they want to do. So, you've got local authorities all over the country, including the GLA. I mean, Selkirk House, for example, missed all the carbon targets. The mayor approved it within days of it being sent to him. Yet he's claiming to be super green, and he's saying London's got this target and that target, and net zero by 2030 and all this sort of stuff. Camden ditto. Yet they're ignoring that. So I think somehow we've got to force these people to do the right thing.
Thank you very much. Thank you all for coming. Thank you to our two speakers.